Okay, let me just send to them. Okay, you can just send the link to your platform. Sorry, because of the network and all, for my network. Okay, I'm very sorry. All you have to do, just share the link and tell them to join. You guys are doing well. Like the persons here are very, very much. Okay. Then now let's solve this question here on rotational motion. Remember, I'm not teaching topic by topic. I'm just teaching those topic that you will see in your exam. Okay, we have treated circular motion. Now the next is rotational motion. So we are trying to take a question from rotational motion here. Remember we are saying about rotational motion there. We are considering revolution. That is a particular movement on what, on a circle. Okay. Now we are trying to know how to convert from degree to radian. You are asked to convert from degree to radian. Now, if you can understand how to convert from degree to radian, that means you can know how to convert from radian to degree. Okay. Now, in conversion here, this is what you should understand here. To convert, you have to know the standard relationship between this particular degree. Please take note. You have to know the standard relationship between degree and what, radian. Okay. Now, just like, for example, if you want to convert from cm to meter, like this, you have to know the standard relationship between cm and meter. That is 100 cm is equal to 1 meter. Now, this is the standard relationship here. So now, what is the standard relationship between degree and radian? We say that, please take note that 180 degree is equal to pi radian. Please remember that 180 degree here is equal to pi radian. Okay. Now it means that this is the standard relationship between degree and radian. So now let's convert this. So 180 degree is equal to pi radian. So that means this side here, this part here should be taking degree. This part here should be taking radian. But 60 degree, we don't know the radian here. That means 60 degree is equal to S radian. We don't know the radian, please take note. So now let's convert. I'm going to cross multiply here using direct proportionality cross multiplication here. That means this will come here. We call this method direct proportionality cross multiplication. This will also times here. Please take note. When you do that, this time this will give us 180 of x is equal to this time this is going to give us 60 pi. So 60 degree times what? Times pi. Please take note. So our intention is to make this s the subject here. Making s the subject of formula here, I'm going to have this. So making s here the subject, that means this will be s will be equal to 60 degree times pi in radian divided by what? 180 degree. Now this can cancel this here. Remember, that means 0 go here, that is 0 here. So divide this by 3, right? Divide this by 3, you are going to get 2. Divide this by 3, you are going to get 6, right? 6 here. 3 will be 6. That is 2 pi over what? Over 6. Okay. Now you can also go, some can also go here. Okay. Now divide this will be 1. Divide this will be 3. That is, this will be pi over 3 in terms of what? Radian. This is my answer here. So we reduce this here. 2 go here, give us 3 go here, give us 2. 3 go here, give us 6. All right. Now let's go here. 2 go here, give us 1. That's 1 times 5, give us pi. 2 here, give us 3. So this is my answer here. Okay. Now the next thing here, we have known how to convert from degree to radian. It's the same way you can also convert from radian to degree. Please take note of that. Okay. Now, whenever you must see a question like this, how to convert under MOS. How to convert from degree to radian or how to convert from radian to degree. Okay. Now let's solve the next question here. Can I clean? Okay. Now let's solve the next question here. Please share, click on the subscribe button so that you can improve the video. For those asking for Mat 120 and Mat 110, our Mat 110 is next week. That is on Thursday before the exam. That's sorry, Mat 120. It is going to be a shortcut class, so you can just join us. It's going to be a physical, not somebody say not spiritual. Okay. Okay, now let's solve this question here. You can solve it for me. Okay, from the question I have here, it means that everything about circular motion is done. So now let's just focus on rotational motion here. Now, class, we are treating rotational motion. Please pay much attention here. Any part that you are going to see in the exam, that is the exam focus area, I will tell you, okay? Now, whenever we are treating rotational motion here, our main intention here is on moment of inertia, okay? And we use I here to represent moment of inertia, okay? Now, whenever we are treating rotational motion here, we use moment of inertia, and we use I to represent that. And this is what you should understand here, that moment of inertia depends on the shape, okay? Now, we are going to write the formula here, the formula for moment of inertia with a different shape. Please take note. Now, in terms of circle here, please take note of that. In terms of circle, the moment of inertia I is said to be m r squared. This is the formula for moment of inertia for circle. Now, let me just try to give you guys more points here. M represent mass, R represent radius of gyration. Please take note. So, whenever you are asked to find moment of inertia, first of all, you check the equation. You know the shape first before you calculate the moment of inertia. If the shape is a circle, that means the formula is going to be this mr squared. But there's some certain question that you might actually come across, and the shape will not be specific. That means they will not tell you that it's a circle or it's sphere or any other thing. Now, at that point, whenever the shape is unknown to us, we always use moment of inertia for a circle. Please take note. Why? Because most of the shape have circle. Most of the shape are comprised of what? Circle. Okay. Now, that is for this. Now, the next thing here is for sphere. That is this. Now, what is moment of inertia for a spherical soft shape? Now, there's a shortcut here so that you guys can easily understand this particular topic. What is the shortcut here? Whenever we are treating moment of inertia here, the first letter, we take the numerator, while the second letter, we take denominator. Please take note. The first letter will take numerator. The second letter will take denominator. Okay. Now, if I want to view this guy here in a mirror, if I want to view this guy here in a mirror here, that means this guy here is taken after 2. Please take note, 2 over. That this guy will take after 2. That is the first one, numerator, over. Now, this guy here will take after P as a letter, converting P as a number here. This is a pentagon. And pentagon is what? 5. This is 5. So I'm going to repeat the formula, which is what? N r squared. Please take note. So this is how we can form sphere. That is moment of inertia for a sphere here. Please take note. So this is the formula for it. So the next one here, the next shape here is rod. Okay. Let's try to write down the moment of inertia for a rod here. We say that the first letter represents numerator. The second letter represents denominator. Okay. When we are saying about rod, what comes into our mind is to hit someone. Please take note. That means I have to take the first letter here. This is the first letter here. It's R. Now divide the first letter. That is, divide this here like this. That means you are having what? 1 and what? 1 like this and 2 like this. Okay. Now that means take the first number. What is the first number here? The first number is 1 over. Take the total number. What is the total number? 1, 2. Now repeat the formula, m arrow square. Please take note of that, okay? All right. Now, this is how to form the moment of inertia for a rod. Please listen. I know you are surprised, okay? We are taking, this is rod here, we are taking the first letter, which is R here. Now, if I'm saying about rod, what comes into our mind is what? Is to hit, okay? Now, that means write your R here. Now, divide. When you divide it, you have 1 and 2. So the first number here is 1. Now, take the total number is what? 1, 2, which is what? Repeat the formula, which is what? M R squared. Now, the last one here, the last shape here, that is disk. The moment of inertia for a disk is said to be, now what is the meaning of this disk here? Is said to be divert 1s. And we know that 1s is 2. That is 1 over what? 2. Repeat your formula, m arrow square. Please take note. So this is the formula for this here. That means these are the formula in terms of the moment of inertia depending on the shape. So if you are given any equation, maybe you are asked to find the moment of inertia for a circle, you just use this formula here. Or you are given any equation and you are that question, the shape or in that question is what? Sphere. And you're asked to find the moment of inertia, use this one here. Please take note. Now, what if it's a rod, you use this one here. If it is this, you use this one here. But if the shape is unknown to us, we always use what? The moment of inertia for what? A circle to solve for that. But this is what you should understand here. Sorry. Now, this is what you should understand here. That sometimes they will give you a question in terms of moment of inertia and also ask you guys to find kinetic energy of that. So what will you do here? Remember that the kinetic energy of rotational motion is said to be this. That is 1 over 2 I omega squared. So if you are given a equation in terms of moment of inertia, depending on the shape, if it's for circle, you use this one here, you calculate your I, you replace it here, and replace this one here. You can easily find what? The rotational kinetic energy. Or they gave you in terms of sphere here, that is this guy here. Please take note of that. You calculate your I using this particular shape here. You replace here, and you replace your omega. You can now calculate this one here. But sometimes the rotational kinetic energy might be given to you, and you're asked to find your what? Your moment of inertia. You can just make this I the what? The solid of formula here. When you do that, you can now find your moment of inertia. Listen please. If you are given moment of inertia, if you are given the rotational kinetic energy, and you are asked to find the moment of inertia, at that point, you use the kinetic energy formula, which is this one here, and make I the subject of formula. Please take note of that, okay? But what you should try to know here is that if you are asked to find the rotational kinetic energy and the moment of inertia is not given to us, you first of all calculate the moment of inertia depending on the shape, either this one or this or this or this. After that, you can now replace it here and replace your what? Your omega. Please understand this. At that point, you can easily calculate your what? Your kinetic energy. Okay. Now let's see if we can see a question like that. Okay. Now, we can't see any question like that, but just try to understand what I'm saying. Okay. Now, let's move to the next topic. You can just write down the formulas. Let's move to the next topic. Please keep on sharing the link so that other person will join up here. Tap on the subscriber button. Okay. For those that are not subscribed, don't only view, try to support the channel also. Okay. Rotational rot, ROT. That's rotational kinetic energy. Now, we are going to move to the next topic. Just write down for us. We are going to move to the next topic. And the next topic we are going to move to is vector in 3 dimensions, which you guys are asking. What you have to do, put down the topic that is giving you more issue. But if that topic is not related to exam topic, I will tell you. Okay, now let's solve some question on vectors. Vectors in 3 dimensions. Okay, please can write. They say it's not clear. Then, okay, but you have moved it. Okay. Please, is it clear now? But is it clear now? Check, is it clear? Let's hear from them. Okay, this stuff. Is it this stuff? Okay, let me check. Where's clear now? What's going on?
Depends what he means.
They say, yeah, let me check. I asked them on the WhatsApp platform.
The message is not. Ah,